Okay, so question number 6. A. Find the area of the parallelogram whose adjacent sides are the vectors u, which is I minus 4j, and v, which is 2I plus j minus 3k. Now, a parallelogram is something that looks like this. Two sides are parallel, the other two sides are also parallel. So two adjacent sides, for example, maybe this is the u they've given, and then this is v. So to find the area of the parallelogram, you just need to multiply u and v. Now the multiplication we are doing here is a cross product, because for vectors there is a difference between a dot product and cross product. So for to find the area, we need to do the cross product. So the area is given by the cross product u times v. And how do you find the cross product? You are going to get u, okay? You are going to get u. So that is, first I'll get j, I'll get k. Please just get them in that order. So please get them in the same order. You always start with I, j, and then k. Okay. And then after that, I'm going to go to the first vector which has been mentioned. That is u. I'll get the number in front of I, that is a 1. Number in front of j, that is a negative 4. Number in front of k, we can see there's no k there, so that will be a 0. And then I'm going to go to the second vector, which is v. Number in front of I is a 2. Number in front of j is a 1. Number in front of k is a negative 3. Now I need to find the determinant of this matrix. So you've seen I've used the straight lines. These straight lines mean determinant. Okay. So the determinant, you can use any row or any column. You need to also take note of this matrix: positive, negative, positive, negative, positive, negative, positive, negative, positive. Take note of this matrix of signs. Now, for you to find the area actually, what you do is you find the absolute value of the cross product. So to find the cross product, you find the determinant. Now, I also need the absolute value, so I'm going to also put another line here, another line here. So the ones inside is meaning determinant, the ones outside is meaning magnitude. Okay, so for me to be able to find the determinant, I'm going to look for a row that has a 0, and that is this row. Second row, so I'm going to get a 1, but notice that I'm supposed to multiply with the sign itself. I'm supposed to multiply by negative, so I'll get negative 1. Okay, and then if I cancel out the row and the column where 1 is, what remains, I find this determinant. So I've got j, k, 1, and negative 3. So I'll multiply this j, negative 3, that is going to be negative 3j. And then minus this one by k, that is going to give us a positive k. After then, I'm now going to come to this number which is on the middle here, and that is a negative 4. Okay, this is a negative 4. Now I'm supposed to multiply it with each sign on the matrix of sign, which is positive, so it will still be negative 4. And then I cancel out the row and the column where 4 is. So we remain with I, k, 2, negative 3. So I multiply I times negative 3, that will be negative 3i, minus 2 times vk, that will be 2k. The next one I was supposed to get is this one, 0. But the reason as to why I even chose this row, because there's a 0. 0 multiplied by anything will still be 0. So I'll not get the last one. Okay, so this is going to give us negative times 3j, that will be positive 3j. Negative times k, that will be positive k. Negative times negative 3i, that will be positive 12i. And then negative 4 times negative 2i, that will be positive 8k. We add like terms. I'll start with the I, so that is going to be 12i plus 3j, k plus 8k plus 9k. Now remember, this is supposed to be in magnitude because we're finding the absolute value of the determinant. Absolute value of the determinant. How do you find that? That is the square root Or if you get a number in front of I, that is 12 squared, number in front of j, that is 3 squared, number in front of k, that is 9 squared. So whatsoever the answer you are going to get here in units squared, like area is given as a unit squared, for example, centimeter squared or meter squared or kilometer squared. So if this question was find the area of a triangle with these adjacent sides, a triangle is half of a parallelogram. So for a triangle, you always put half in front here, half, and then you say dot product, magnitude of the dot product. Any question? Are we good? Are we together?
Sir, just a minute.
Yes.
You see, I'm trying to comprehend what you're doing right now, and all I can see is in this matrix a 2 by 3 matrix.
It's a 3 by 3.
Three, so are we including the IJK as well?
Yes, you include those also. That's why I even put them there, because you can't find determinant of a 2 by 3 matrix. Like the rows and the columns should be the same. At least at this our level, we don't know anything about anything that has which doesn't have similar rows and similar columns. Should be similar. 2 by 2 or 3 by 3.
All right.
Okay, so this is going to be the area, square root of 234 units squared. If it was a triangle, I would have put a half in front here because we get to multiply by half. So the next question, solve the following systems of linear equations. It is equation in three variables. Now, when you want to solve such an equation, please, you are not restricted. It's up to you. For this question, it's up to you to choose whatever method that you use. That's why I liked about this paper. Like they didn't specify what method for you to use. You can use elimination, you can use substitution, you can use determinant method, that is Cramer's rule. You can use the inverse method, you can use the graphical method. Whatever you want to use yourself is up to you. So what I'm going to do is I'm going to use substitution method because it's much easier. For the first equation, I'm going to make x subject to the formula. So I'll say x is equal to 2, I'll take y the other side plus y. So be equation 1. I'll go in the second equation. Where there is x, I'll put 2 plus y. So that will become, where there is x, I put 2 plus y. Okay, I've substituted here. And then plus y minus z, and that is equal to negative 3. So this is going to, I'll take the 2 the other side. So I'm going to have 2y plus y, that is a 2y minus z, and that will be equal to, if 2 goes the other side becomes negative, that will be negative 5. This is going to be equation 2. I can as well make z the subject formula for equation 2. I'll take z the other side of the equation, and then I'll bring 3 also the other side of the equation. So it becomes z is equal to 2y plus 5. It's not a 3, it's a 5. So I'll bring 5 the other side of the equation. So this is equation 2. And then the same x, I'll go in the third equation. Where there's x, I put 2 plus y. So that will be 2, pen brackets 2 plus y minus y plus 3z is equal to 0. So this is going to give us 4 plus 2y minus y plus 3z is equal to 0. Okay, I'll add 4 and 3, that will give us a 7. 2y, oh, this is 3z, so we can't add. 2y minus y, that is just a y, plus 3z. This should be equal to, I'll take for the other side, that will be equal to negative 4. This is going to be equation 3. In equation 3, where there is z, I'm going to substitute this. Okay, I will substitute 2y plus 5. So that becomes y plus 3, open brackets, 2y plus 5, and that is going to be equal to negative 4. So this will give us y plus 6y plus 15 is equal to negative 4. Y plus 6y, that is 7y. Take 15 the other side becomes negative 15 minus 4, negative 19, meaning that y is equal to negative 19 over 7. Okay, from here we can now find z. I'll come and substitute in this equation which is here. So z is going to be equal to 2 multiplied by y, is negative 19 divided by 7, and then that is plus what? That is plus 5. It is 2y plus 5. And this will give us z being equal to 2 times 19. What is 2 times 19? Negative 38 over 7 plus 5. Now to make the bases the same, I'll multiply on top by 7, even the denominator by 7. We know 5 times 7 is a 35. So since the bases are the same, I'll just get the denominator, okay, which is a 7. And then I'll add on top. We have got negative 38 plus 35. That will give us a negative 3. So that's the value for z. And to find the value of x, I'll go in the first equation. So x is going to be equal to 2. Where there is y, I'll substitute. What is the value for y that we found? So y we found is negative 19 over 7. Just to make the bases the same, I'll multiply on top by 7, even down by 7. So then y becomes, since we have got the same denominator, I'll put it down. So this negative and this negative will become positive. So 2 times 7 is 14. So we have got 14 plus 19, which is, of course, this is a 3. That was supposed to be 13. 3 remainder 1. Then another 3 there. So that is going to be 33 over 7. So that is it. Y is a 3 over 7. Z is negative 3 over 7. And what else did I calculate here? So this is actually x. And then y is negative 19 over 7. So that is it for this one. And such questions, they carry a lot of marks. So be sure to get it. Please, if there's a question, be free to ask. Is there a question? Do you have anyone who is having a question? Matilda, are we okay?
Yes, we're okay.
All right. Differentiate f of x, which is equal to square root of 1 minus x, from the first principle. So from the first principle, we know that f prime of x, which is the derivative, is given by a limit as h approaches 0 of f of x plus h minus f of x divided by h. And this gives us limit as h approaches 0 of f of x plus h. So I'm going to get the function itself, but where there is x, I'm going to put x plus h. So that is going to be square root of 1 minus, where there was x, I put x plus h. Now it has become negative x, negative h, because I was supposed to write 1 minus, where there was x, I was supposed to put x plus h. But I've just distributed this negative. That's why I've seen everything is negative. And then minus f of x. F of x itself is square root of 1 minus x divided by h. So this is going to give us limit as h approaches 0. Now I'm supposed to rationalize this one. Now since I don't have enough space for me to write on that page, what I'm going to do is I'm going to rationalize it from this side. And then I'll just write the answer there. Okay, so we have got the square root of 1 minus x minus h minus square root 1 minus x divided by h. So to rationalize, multiply on top by the conjugate of the numerator, so to be square root of 1 minus x minus h. Now change the sign, it becomes plus square root of 1 minus x. Also down, we are going to have square root of 1 minus x minus h plus square root of 1 minus x. Now on top here, if you multiply a number by its conjugate, like a surd by its conjugate, just get the first one, square it. Always get a minus. It doesn't matter if the first one which was here was negative and then this one was positive, or the other way around. As long as it's surds, when you multiply a number by its conjugate, just get the first one square. So if I get the first one, square root of 1 minus x minus h squared, it will just be 1 minus x minus h, because the square root will cancel. And then I'll get a minus. I square the second one, the root will go, I'll just remain with 1 minus x. And then divide. The denominator we have got, h will multiply with the square root of the square root there. So that will be h square root of 1 minus x minus h. Okay, this was supposed to be plus square root of 1 minus x, like that. So if I distribute a negative, this will be negative 1. It will cancel with this 1. If I distribute this negative, it will become positive x. It will cancel with this x. We'll just remain with a negative h on top. And that negative h will cancel with the h down. So we'll just remain with a negative 1 on top. And then in the denominator now, we are going to just remain with square root of 1 minus x minus h plus square root of 1 minus x. Now from here, now substitute where there is h. That will be negative 1 divided by square root of 1 minus x. Where there is h, I've put a 0. And then plus square root of 1 minus x. Square root of 1 minus x plus square root of 1 minus x, that will give us 2 square root of 1 minus x. So this is the derivative for square root of 1 minus x. Are we good? Any question? Haggai, are we okay? Do you have any questions? It seems it's only Matilda who answers, so I'll just be asking Matilda. Matilda, are we okay?
Yes, you are very fine.
All right. So find dy over dx if y over x squared plus 2y squared x is equal to sine of x. To make things easier, I'm going to take the x on top so that it becomes y, x to the power negative 2 plus 2y squared x is equal to sine of x. Just before we do anything, I've always written this. Take the y-axis as sin, negative as negative sin, x-axis as cos, negative as negative cos. As you go in this direction, it shows that you are differentiating. If you differentiate sin, you are going to get cos. Take note of that. So we're going to now write d over dx, meaning the derivative with respect to x. So here we have got yx to the power negative 2. That is a product. I'm first going to maintain y, okay, from the product rule, v du over dx plus u dv over dx. I'll maintain y and then I differentiate x, that will be negative 2 x, subtract a 1, becomes negative 3. If I differentiate x, I was supposed to add dx on top here. It becomes dx over dx, but dx over dx is a 1, so I'll just end there. And then plus, now I'll maintain the x to the power negative 2. Okay, I differentiate y. If you differentiate y, you are going to get 1. Every time you differentiate y, you need to add y on top, so it becomes dy over dx. Okay, I've added y here. And then if I'm done with that, I'll come to this one, 2y squared x. I'll first remove a 2 because it's a constant. Okay, I'll keep y the same way it is, y squared. I differentiate x, that will be a 1. And then plus, I'll keep x the same way it is. I differentiate y, that is going to give us 2y. This is y squared, so if I differentiate it, it gives us 2y. But every time you differentiate y, add dy over dx. So I'm done with this part, and then is equal to, I differentiate sin at the end, that is going to give me cos x. Ah,
Okay, just get after you just
yes.
put y then sine x. If that was sine y, would it have been this unit
Yes, so if it was sine y, what we do is actually differentiate sine, keep the angle the same way it is, it gives you cos, you write the y the same way it is, and then differentiate the angle. If you differentiate y, it will give you 1. Every time you differentiate y, add dy over dx. So you first differentiate the ratio and then you differentiate the angle. But if I differentiate x, it will give me 0. So that's why I've not even, I mean, it will give me 1. That's why I've not spoken about it. All right. So again, we now go on and multiply y multiplied by negative 2x. That will be negative 2y. Now the x, notice that it has got a negative 3 power. I'll bring it down. It becomes positive 3 power. And then plus we have got x to the power negative 2 dy over dx. So I'm going to write it as 1 over x to the power 2 positive 2. And then I'll write dy over dx here. Okay, and then you have got 2 multiplied by y squared. This is going to be 2y squared. We have got this is, what is this a 2y? Okay, that is a 2y dy over dx. So we have got a 2y. We to multiply with this x, that will be 2xy. It multiplies again with this 2. That is going to be 4xy dy over dx. And this is going to be equal to cos x. And then those which have got dy over dx, I'm going to factorize it. So we have got this one and this one. I'm going to factorize out dy over dx. For the first one, we're going to remain with 1 over x squared, plus the second one, we're going to have 4xy. And this is supposed to be equal to cos x. I'll get this term, take it the other side of the equation, positive 2y over x cubed. Is that x cubed? Yes, it is. Okay, so after doing that, I want to merge this as a single fraction. So that is going to be dy over dx. Merge it as a single fraction, so it's going to be over 1. So multiply 1 on top by 1 down here. That is going to be a 1 plus this x squared down with the 4x on top. That is going to be 4x cubed y. And then multiply the two denominators. That will just be x squared. And this is going to be equal to also this merge as a single fraction. Cos x times x cubed, that is going to be x cubed cos x. Please don't write cos x to the power 4. The x cubed will multiply the cos and not the angle. And then 1 which is down times the 2y, that is going to give us a 2y. Divided by multiply the two denominators, that is going to be x cubed. So from here, I want to only have dy over dx. So I'm going to find the reciprocal of this thing which is attached to dy over dx, and that is going to be x squared over 1 plus 4x cubed y. So if I multiply this term with this term, they'll cancel out. I'll just remain with dy over dx. And then if I multiply this same term with the other side of the equation, notice that the x squared will cancel, just remain with 1x here, right? So we are going to have x cubed cos x plus 2y divided by down we have got an x. So this x multiplies with a 1, that becomes x, plus this x multiplied with a 4x cubed y, that will be 4x to the power 4y. So this is a derivative. I hope it is okay. At least just say something. It is okay or it is not. Other than, are we good? Or people are confused? Matilda, are we good?
Yes, you're okay.
Okay. And for this one, for this other question here, if you don't want to ask, actually, I'll not even ask if people are good because I know the question. Find the intervals where f, consider the function f which is defined by f of x being equal to x cubed plus 2x squared minus 2. Find the intervals where f is increasing and where it is decreasing. So to find where it is decreasing and increasing, find this derivative f prime of x. That is going to be drop the 3, reduce the power by 1, drop the 2, 2 times 2, that to become 4, reduce the power by 1, and then the constant will be 0. So equate the derivative to 0. 0 is equal to 3x squared plus 4x. Factorize out x to be x, open brackets, 3x plus 4 is equal to 0. Equate them to 0, so x is equal to 0, or x is equal to negative 4 over 3. So these are the turning points of this function. But I want where the function is increasing and where the function is reducing or decreasing. What am I going to do? I'm going to get the factors which are equated to 0. I have x. I also have 3x plus 4. What are the values I found? I found negative 4 over 3. I also found 0. Please, this is a number line I'm writing, so make sure that if the value is smaller, you put it. And then what we're doing with these values, we are multiplying them, so we'll look for the product. So when I equated x, this x to 0, I found 0. So meaning that as long as I talk about values of x greater than 0, it will be positive. Like get any value which is positive, put where there is x, it will be positive. Anything less than 0 will be negative. When I equated the 3x plus 4 to 0, I found negative 4 over 3. Meaning that anything above negative 4 over 3, think of a 0, you put in 3x plus 4 to be positive. And anything below, the sign will change. So negative times negative, positive. Positive times negative, negative. Positive, positive, positive. So at every point where I saying positive, that is increasing. So the function is increasing from negative infinity to negative 4 over 3. You can't include negative 4 over 3 because that's the turning point. And then union from 0 to positive infinity. And then the function is decreasing between negative 4 over 3 and 0. And you can't include, that's why I'm using open interval brackets, because those 2 points are turning points. So that is it. The next question. Find the relative maxima.
Can even see, and I'm sorry, just a minute.
Yes.
I think if you extend the graph,
Which one?
this same graph you're pointing on,
This one I'm writing signs on.
yeah,
Okay, so all you do is find the derivative of the function. After you find the derivative of the function, equate it to 0 to find the values of x. And then after you equate it to 0, get those factors which you equated to 0. See how they are going to be behaving for those values of x that you have found before, between, and after, like just the behavior of the function. So that is why I've written negative 4 over 3, and I've also written 0. I put the factors I equated to 0. We've got x and 3x plus 4. So remember when we add x, we equated it to 0, it gave us 0, right? Meaning that if I get any value above 0, it's still going to be positive. Like the function is going to be positive. For example, 1, 5, 6, 7 is positive. If I get any value below 0, like negative 1, negative 5, it will always be negative. And then when I equated 3x plus 4 to 0, I found negative 4 over 3. If I get any value above negative 4 over 3, think of a 0 or a 1, I put here, it's going to be positive. Immediately I cross the negative 4 over 3, it becomes negative. Okay, like you can think of a negative 3, you put it there to be negative. Now you multiply these signs, negative, negative, positive, negative, positive, negative, positive, positive, positive. So that is what you do when you're finding where the function is increasing and decreasing. Are we good?
yes, yeah.
All right. The next one, find the relative maxima, minima, and the point of inflection. To find that one, since we want to also determine the point of inflection, first we found the first derivative. The first derivative was equal to 3x squared plus 4x. Find the second derivative, f prime prime of x. Second derivative will be 6x plus 4. If you equate the second derivative to 0, that will give you a point of inflection. Okay, so 0 is equal to 6x plus 4, meaning that 6x is equal to negative 4. Divide by 6, x is going to be negative 2 over 3. This is the x value of the point of inflection. To find the y value, go in the actual function. So y is going to be equal to negative 2 over 3 to the power 3 plus 2 multiplied by negative 2 over 3 to the power 2 minus 2. Negative 2 to the power 3, that is negative 8. 3 squared is a 27. Then plus 2. Negative 2 squared is a 4 times 2, that will give us 8 over 3. I want to make the bases the same, so I'll multiply on top by a 9, also down by a 9, so that 9 times 3 will give me a 27. Then the negative 2, to make the bases the same, I'll multiply on top by 27, even down I'll multiply by 27. Like, since we don't have a calculator to use. So since the bases are the same, like down here, 3 times 9 is 27, 27, 27. I'll just write a 27. And then on top now, I'll just be working out what we have. We have got negative 8. And then we have got, what is 8 times 9? This one we can easily, okay, 72. And then we have got negative 2 times 27, which is a 54. So just get to do the addition. So I'll write here the point of inflation. That is that the x value is negative 2 over 3. The y value, negative 8 plus 72 minus 54. What do we get? So that is basically 72 minus 54 minus 8. So that will be 10 over 27. This is the point of inflection. And then we want to also find the relative maxima, the relative minima. So there are two methods to do this. You can use the first derivative by using a tabular method, or you can just look at the second derivative. Now, for the second derivative, those points, remember at the beginning, which I equated to 0, which I found, which I said they are turning points. If in the second derivative you put that value, it gives you 0. I mean, it gives you a negative number, that's maximum. If it gives you a positive value, that's minimum. So the first value I found was negative 4 over 3. Let me put in the second derivative. That would be 6, negative 4 over 3 plus 4. Okay, this is going to be negative 8 plus 4, which is equal to negative 4. Since the second derivative, d2y over dx2, which we can also say f prime prime of x, is negative, then this means it's a maximum. So the maximum value is at negative 4 over 3. Now we need to find the x value. You find the derivative for this one and then you equate it to 0. All right, so now get the other value which we found. When we found the derivative and equated to 0, found 0. So get 0 you input in this function, the second derivative. You'll see that you are going to find 6 times 0 plus 4, which is 4, positive, meaning that that is actually this one which it has given us a positive. A positive means minimum. Okay, so that is 0 comma. Now I don't know the y value, so go in this function, substitute where there's x, you put 0. That will give you a negative 2. So 0 comma negative 2 is a minimum. Let's find the y value for the maximum. That's the relative maximum. So we'll get the function f of x is equal to x. So where there is x, I'll put negative 4 over 3. Well, this is actually negative, yeah, it's negative 4 over 3 raised to the power 3 plus 2 multiplied by negative 4 over 3 raised to the power 2 minus 2. So this will give us negative 4 to the power 3, negative 64. Let's hope it is. 3 to the power 3, 27. Negative 4 squared, that is a positive 16. 16 times 2, Is it here 32? And then down you are going to have 3 times 3 squared, which is a 9. To make the bases the same, I multiply by 3, also on top by 3. And then we have got here 2. But to make the bases the same, multiply by 27, even down by 27. So since the bases are the same, I'll put the 27 down. So on top I've got negative 64 plus, what is the 2 times 3? 96 minus 2 times 27. Is it a 54? And then we are going to get to subtract. So basically what we have is 96 minus 54. Again, another minus 64. So that will give us a negative 22. So negative 22 over 27. Okay, so this is it. So we have answered part 1 and part 2. The next one, sketch the graph now. Interesting part. Sketch the graph. And how do we get to sketch the graph? First thing first, I'm going to find, like, I'm going to get the first derivative. Okay, the first derivative. Remember, for the first derivative, we found the increasing and the decreasing. So those are the ones I want to write, okay? And then the second derivative when we equate it to 0. So I'm going to write something like this. On top, I've got f prime. And then down, I'm going to put f prime prime, meaning second derivative. First derivative gave us two values. Second derivative gave us one value. The first derivative, we had 0 and negative 4 over 3. Second derivative, we had 0 and negative 4 over 3. Second derivative, we had negative 2 over 3. Now, my question is, which one is bigger between negative 2 over 3 and negative 4 over 3? Can you help me, please? Which one is bigger? Let's go on. Matilda.
Negative 2 over 3.
You people are fun. Okay, so like negative 2 over 3, you've seen that the difference, the denominator is bigger than the numerator, right? That means that this number is small. And then negative 4 over 3, the denominator is smaller than the numerator, meaning that this number is big. But for negative numbers, what look to be big is small. So negative 4 over 3 is much smaller. And then negative 2 over 3. Because if you miss this direction, you get it bad. Okay. So now what we are going to do from here, look at the signs which it gave you. We've seen that from negative infinity to positive, from negative infinity to negative 4 over 3, it was increasing, meaning that it gave us a positive value, right? From negative 4 over 3, and then from negative 4 over 3 to 0. Like you can look at this, from negative 4 over 3 to 0, it was decreasing, meaning that it gave us a negative. Okay. And then from 0 to infinity, it was still increasing, so there is a positive. And then down. Now, if you look at the denominator, we are talking about the second derivative. You found negative 2 over 3. Okay. So what you are going to do is, what happens if you get values of x greater than negative 2 over 3? We put in the second derivative. The second derivative we found was what? It was, what's the value we found? When we found the second derivative, was it 6x plus 4? So if I get values of x like greater than 6x plus 4, for example, greater than, because this is a second derivative which we equated to 0 to get negative 2 over 3. What happens if I get values of x greater than negative 2 over 3, for example, a 0, I put here, it will be positive. And then as long as I cross the negative 2 over 3, it is going to be negative. Okay, now every time you see first derivative is positive, just know that the line is going to be going up. It can go up like this or it can go up like this. Now, when the second derivative is positive, just know that it will be going in the clockwise direction. If the second derivative is negative, it will be going like this, to be decreasing. So if you look at the first one, let me even change color. First derivative is positive, meaning it will be going up, but second derivative is negative, meaning it will be going like this. Okay, at a decreasing order. If you look at the other ones, first derivative is negative, meaning the line will be going down. Second derivative is also negative, meaning that it will be going down at a decreasing order like that. If you look at between negative 2 over 3 and 0, first derivative is negative, meaning it will be going down, but second derivative is positive, meaning that it will be going clockwise but down. Okay, it will be like that. And then for the last one, first derivative positive means that the line will be going up. It is second derivative is also positive, meaning that it will be going clockwise, anti-clockwise. So it will be going like that. So this is how the graph is supposed to look. You can now sketch. That's why we say that negative over 3, the function is supposed to be maximum. You can even confirm the way it is moving that it is maximum at that point. At negative 2 over 3, we can see there's a change of direction at negative 2 over 3. That is what we call a point of inflation, a change of direction. Okay, so we can now get to sketch the function. So I'm going to put a graph. So the x values we have is negative 4 over 3. Let me just say negative 4 over 3 is here. And then we also have 0. Those are the x values. We also have negative 2 over 3. So let's say negative 2 over 3. Where can it be? Negative 2 over 3. Let's say it's here. Okay. But remember, we have coordinates at the point of inflation, negative 2 over 3, comma 10 over 27. 10 over 27 is a number that is less than 1. So if 1 is here, 10 over 27 will be much lower than 1. Okay, so that will be negative 2 over 3, comma 10 over 27. Let's say it will be somewhere here. The thing is, I just have to label that point. Okay, the next one, this is a point of inflation. That's where the points are going to be changing. And then I've got negative 4 over 3, comma negative 22 over 27. Mean that this is going to be on the negative side. Negative 22 over 27 is also a number that is smaller than negative 1. Like, anyway, bigger than negative 1 since these are negatives. So if negative 1 is here, meaning that it's going to be somewhere just near but below. So that would be negative 4 over 3, comma uh, negative 4 over 3, comma negative what? Comma negative 22 over 27. Okay, and then the next one we have got 0, comma negative 2. 0, comma negative 2. Negative 2 will be somewhere here for the y. So it will be like here. So we are now supposed to see how the function is going to move. This question, I think I answered it even last time. It seems the y value for the point of inflation that I've been finding is wrong. This was then supposed to be, I think it was supposed to be negative 10 over 27. Okay, because at this point, the function is going to be going up. Okay, the function is going to be going up until it reaches negative 4 over 3, it starts coming down. Okay, so that's why I'm saying like this one was supposed to be somewhere like negative instead of positive 10 over 27. I think it was supposed to be negative 10 over 27. That means it will be like somewhere down there. And then as you get to reach that point, when you reach this value, you're supposed to start changing directions. Okay, you start changing directions. It goes like that. And then at the point of inflation, that is where the change of direction is going to go. That's where the function will be going something like this. Okay? And then this will be the minimum at what? The minimum at 0, comma negative 2. And then you start going up. Now from this function, you can see when y is 0, what will be x? Well, I don't know that, but just know that the function will now go like that. So this is how the function is supposed to look, like that. So it makes like this and this. Okay, I hope that is okay, but that is how it is supposed to be. So just please double check the sign here. It was supposed to be negative. It was supposed to be a negative y value, not positive. Are we okay? Matilda, are we okay?
Yes, okay, sir.
Okay, that's nice. Question number 7. This one is even much simple. You might find they bring a rational graph for you to sketch. You'll cry. Rational graph using calculus. But it's that's the same procedure anyway. You can't cry. You people are intelligent. Question number 7. Find the indefinite integral of natural log of x. Now, when you have got a product of two functions and they've got the same power, like here we've got x and we've got natural log of x. The only method you have, like the best method you have, is by parts. Now, integration by parts has got another simple formula, which we call as tabular method. So the tabular method is that simple. I don't want to show you the by parts formula because the integral of u dv is equal to uv minus the integral of v du. Like, it will confuse you some bit for you to find v, but it's very simple anyway. But it will confuse you some bit. So what I'm going to do is I'm going to write a column of signs, derivatives, and integrals. Now, please, I'll mention it again if you didn't attend the other class which we had. When you are integrating, when you're integrating something that has a natural log, please never put natural log under this I, the integral, because you don't know the integral of natural log. Actually, just for you to integrate natural log, you need to use this same formula. Natural log alone, you need this formula. So I'll put the natural log under here. But if it wasn't natural log, I would have put, for example, if it was x e to the power x, I would have put the e to the power x under integral and the x under derivative, because the m should be, I put something under derivative that I can differentiate for me to get a 0. And I know if I differentiate x 2 times, I'm going to get a 0. That's the m. But if I put x under derivative and natural log of x under integral, like I'm doing nothing. There's nothing I'm doing. And then I'm going to put x here. So what I'm going to do is I'm going to differentiate x. If you have forgotten, for you to differentiate a natural log, just differentiate also ever natural log of x, differentiate this thing. That will give you 1. And whatsoever you differentiated, that's x divide. So if it was natural log of x plus 5, let's say plus 4. If you differentiate it, will give you 1. Divide by the same thing, x plus 4. Okay? And then I'm going to integrate x. That is going to give me x squared over 2. So I'll just end here. And then I'm supposed to always start with a positive and then a negative. Okay, so that is how you're going to work it out. And then you are going to say, you are going to multiply diagonally. This one times this one times a positive. Okay, positive times natural log of x times x squared over 2. That is going to give us x squared over 2 natural log of x. That's the only diagonal. And then I'm supposed to also multiply horizontally. Since there is no 0 here, I'm supposed to multiply horizontally. So negatives times 1 over x times x squared over 2. X will cancel with x, so just have x over 2. But whenever I multiply horizontal, you need to put integral. That will be integral of x over 2. Every time you have this, always remember to put dx because we're integrating with respect to x. By the way, if you're not good with these integrations, I've got very, very nice videos talking about specifically each method of integrations. Use substitution, change of variable. There are also some special cases of change of variable by parts, the tabular method. Very nice ones. Okay, so this is going to be equal to x squared divided by 2 natural log of x minus. The 2 in the denominator is a constant, so I'll remove it outside the integral. And then we're just going to remain with the integral of x dx. So this is going to give us x squared divided by 2 natural log of x minus 1 over 2. If you integrate x squared, that will give you x over 2. The same power 2 bring it also down, and then add the constant c. So this is the answer. If I want, I can factorize out x squared over 2. On the first one, we're just going to remain with natural log of x. For the second one, we just remain with 1 over 2. then plus c. So this is it. Or if I wanted, I would have just multiplied 1 over 2 times x squared over 2. So that is how you integrate such a one. The next one. The next one. Find the integral of 1 over 1 x plus x squared. So directly looking at this one, you can't integrate it. You first need to make it as a partial fraction. So this is the same as 1 over x open brackets 1 plus x dx. So meaning this should be expressed in the form a over what is in the denominator is x, and then plus b over 1 plus x dx. So I need to find the value for a, I need to find the value for b. So I'm going to say this is 1 over x 1 plus x being equal to, I'll multiply the a on top with the 1 plus x, that would be a 1 plus x. I'll multiply the b by the x, that will be bx, and then the denominator multiply them also, that will be x 1 plus x. Since the denominators are the same, equate the numerator. So that will be 1 is equal to a 1 plus x plus bx. If I want to find the value for a, make x be equal to 0. If I put 0 here, that will be 0 times b, which is 0. I put also 0 here. That will be 1 plus 0, which is 0. I mean 1 times a, which will be a. So meaning that a is going to be equal to 1. If I want to find the value for b, make a be equal to negative 1, right? If I put negative 1 here, 1 minus 1 is going to be what? 0. 0 times a, it will be 0. And then also put negative 1 here. So it will be 1 is equal to negative bx, meaning that b is equal to negative 1. So that is it. So I'm going to go on and substitute there. So this is called integration by partial fractions. So this becomes, where there is a, we put 1 divided by x integral. Let me do this. Okay, the integral of 4. And then where there is b, we put negative 1 divided by 1 plus x dx. Friends, when you have got the derivative d over dx of natural log of x, this is 1 over x. Meaning that if I've got the integral of 1 over x, it should give me natural log of x. Every time you've got something that is in the form 1 over, you should think of a natural log. So first I'm going to split this. That is going to be integral of 1 over x dx. And then I'll get a minus integral of 1 over 1 plus x dx. I'm not forgetting the dx is just telling me that I'm integrating with respect to x. So the integral of 1 over x is natural log. Always don't forget absolute value, because it's always positive. Natural log absolute value of x. So when I'll just get natural log, and so whatever is in the denominator, I get it. But don't forget to differentiate what is in the denominator. If you differentiate x, you're going to get 1. So I was supposed to divide this thing by 1, but anything over 1 is itself. And then minus. This will also be natural log of what is in the denominator, 1 plus x. But I was supposed to differentiate what is in the denominator, 1 plus x. That will still give me 1. So I was supposed to divide this by 1. And then just add the constant c. So this is the integral for this one. Matilda, confirm for others if it is okay. Guys, are we okay? Are we following? Oh, nice. Okay, consider the function f defined by f of x being equal to the absolute value of x plus the absolute value of 1 minus x. Redefine f by removing the modulus. So it's a nice question. Redefine. Wow. So to redefine this function, I'm going to get this equated to 0. So I'm going to find that x is equal to 0. I'm going to get this and equate it to 0. You are going to find that 1 minus x is equal to 0, meaning that x is equal to what? 1. After you equate those to 0, remember we have got absolute value. So I'm starting to redefine. So I'm going to say f of x is equal to, so before I say is equal to, I'm going to get these two functions, okay? We equated x to 0. When we equated x to 0, we found 0. So I'm going to write this comma table, x is equal to 0, and then x is equal to 1. So the values we equated to 0 have got x and 1 minus x. When I equated x to 0, I found 0. So anything positive, I put it in x, it will be positive. Anything below 0, it will be negative. When I equated 1 minus x to 0, I found 1. Anything above 1 will give me negative. Think of a 2. 1 minus 2 is negative. Anything as long as I cross the, the sign here is going to give me positive. Now we get to start redefining the function. So I'm going to say f of x is equal to, I'm going to write it like this. So we have got three regions. We have got numbers below 0. We have numbers between 0 and 1. We have got numbers above 1. Now, yes, Mr. Hagai. Or maybe it's a madam. Yes? Okay. Okay. So what we are doing is this. Equate x to 0, I'm going to find 0, right? I'm going to write that 0. I'm going to write that 0 which I found when I equated x. And then equate 1 minus x to 0, I'm going to find 1. I'm going to write 1. Then I'll get those factors which I've equated to 0, which is the x and 1 minus x. So if I'm looking at x, when I equated it to 0, I found what? I found 0. So think of any number above 0, like a 1. Put it where there's x, it will give you positive. Think of any number below 0. Any number, any. Negative 1, negative 7, negative 5. Put where there's x, it will always be negative. So as long as you cross that value that you found when you equated to 0, the sign changes. When I equated 1 minus x to 0, I found 1. What happens when I get any value above 1? Any. I put in where there's x. For example, 2 or 3 or 5 or 7 to give me a negative value. Meaning that as soon as I cross the 1, this should give me a positive. Because at 1 itself is supposed to give me a 0. Okay, 0 is the distinction between negative numbers and positive numbers. So this is how we got it. I don't know if it's okay now. All right. So now we can redefine the function f of x. So look. So when you have got 1, you get values of x greater than 1. Look for a 2. You put here. What are you going to get? What's 1 minus 2? Okay, so we are now redefining. So I'm going to get this without absolute bars. Okay, without absolute bars. So that is going to be x and then 1 minus x. We've seen how I've put it. I haven't put anything. I haven't put, let me put a plus which was there, and then I'll write this in brackets like that. Okay, and then I'll again write x plus 1 minus x. I'll again write it x plus 1 minus x. Now we have got values which are less than 0. So I'm going to say for x is less than or equal to 0. And then you have got values between 0 and 1. So I'm going to say between 0 is less than x, which is less than or equal to 1. And then for values of x greater than 1, x is greater than 1. Some of you might ask, why are you putting at some point, you're putting less than or equal to at some point, just less than? All I'm doing is I just want to make sure that the function is continuous. In other words, this isn't breaking. So I've seen for here I'm including 0. Obviously, even if I don't include the 0 here, it will still be included in the function. Here I'm including a 1, here I'm not including a 1, so nothing changes really. So all I'm doing is I just want to make the function continuous. If you want, you can put everything x is less than or equal to you can put everything. Now, if you look at x, for values of x less than 0, the sign is what? Negative. Meaning that for the first equation where it is less than 0, for x I'm supposed to attach a negative. And then for the 1 minus x, for values of x less than 0, it is positive. So I was supposed to attach a positive, but nothing will change. For between 0 and 1, for x, it is positive. So I was just supposed to attach a positive. For 1 minus x, it's also positive. So I was supposed just to attach a positive, but nothing really changes. Now, for values of x greater than 1, x is positive, so I'm supposed to attach a positive here. 1 minus x is negative, so I am supposed to attach a negative here. And then from there, we just simplify this. So this becomes positive times 1 times negative x, that will be positive 1 minus x. Okay, so this is going to give us, I'll first write positive 1, negative x minus x is negative 2x. This is for values of x less than or equal to 0. Okay, here, if I distribute the positive to what is inside to give me positive 1 and negative x, so the x and the x will cancel, just remain with a 1. So 1 for 0 is less than x, which is less than or equal to 1. And then if I distribute here this negative, it will be negative 1. This negative, it will be positive x. So positive x plus x, that will be 2x. And then we're going to have a negative 1 for values of x greater than 1. So what I've done is I have redefined the function. So this thing you're seeing down here is a function redefined. So I can now remove this. I have redefined. Any question? No question? It is okay. All right. And then the next one, sketch the function or the graph of f. We can now go on and sketch. These are x values. We have got y values there. Remember, the point of interest is that 0 and that 1. So I'm going to, let me say a 1 is here, then a 0. We know it's there. Now, this first equation is only valid for values of x which are smaller than 0. Meaning that starting from 0 itself, if I get 0, I put in this function. What is the y value I'm going to find? I'm going to find a 1. So I'm going to have 0, comma 1, which is a coordinate here. If I get negative 1, I put in this function. What am I going to find? 1 minus 2 times negative 1. That will be positive 3. This is 1. This is positive 3 will be somewhere here. So that will be negative 1, comma positive 3 to be somewhere here. Two lines, 2 points are enough for a straight line. I'm just joining this. It's the straight line. And then, as long as you have got values of x between 0 and positive 1, your y value is supposed to be 1. So between 0 and positive 1, the y value is supposed to be 1. So they're supposed to be like that. And then for any value of x, as long as it is greater than 1, you are supposed to use this equation. So put 1 in there, 2x minus 1, you are going to get x being equal to 1. I mean y being equal to a 1. Let's see, it will be, okay, it will be a 1, yes. Like put get x, you put into x plus 1, it will be 1, which means it is at this very point. And then get a 1, any value above 1. Get a 2. 2 times 2, 4, minus 1, that's a 3. So if the value of x is 2, that means y is going to be a 3. So it will be somewhere here. Remember, we have found one coordinate to be here, another one to be here. Just join these. So this is the graph of this function. And that is it. I hope it is okay. I hope it is okay. Yes, yes, Catherine. Like you can just get anything. For example, the function which you said it was 1 minus 2x, this one. We said it is only valid for values of x less than 0. Meaning you can get any value of x as long as it's less than 0. Starting from 0 itself. If I put 0 into this function, it will give me, actually I've even swapped it, but let's say this was the function. Get 0 itself, put in this function, I'm going to get a 1, right? And then get a number less than 0, like any. It doesn't matter. We are looking at the range, the thing at the end. Any value, like a negative 1 I put in this function, it's going to give me a 3 here. So it means that when y is 1, x is going to be 3. I mean, when x is equal to 1, y is going to be equal to 3. So you just look at the range. That's what we are looking at. I don't know if that is okay or not. All right, thank you. Next one, question C, part 1. Find the area bounded by the curve y is equal to x minus 1, x minus 2, and the x-axis. First thing first, for such a question, you first need to sketch it for you to be able to find the area. And how do you sketch such a function? Just equate it to 0. We are going to find that x is going to be equal to 0, x is going to be equal to 1, x is going to be equal to 2. So just equate this function to 0. So I have 0, 1, and 2. So you need to see how this function is going to be behaving between these different points. Although I wasn't even supposed to anyway, it's necessary. So we need to see how the function is going to be behaving again. So I have got x minus 1, I have got x minus 2. When I equated this to 0, I found 0, I found 1, I found 2. When I equate x to 0, I found 0. Any number above 0, it will give me positive. Anything below 0 should be negative. When I equate x minus 1 to 0, I found 1. Anything above 1, it will be positive. Anything below will be negative. Equate x minus 2 to 0, find 2. Anything above 2, it will be positive. Anything below, it will be negative. Remember, these points are multiplying, so I'm looking for the product. Negative, 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 this will be negative. Positive, negative, negative, positive. Positive, positive, negative, negative. Positive, 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 positive. So I mean that between 0, I mean for values of x smaller than 0, the function is supposed to be negative. Okay, it's supposed to be negative. So anyway, by the way, these points that you're able to see are turning points. When y is equal to 0, you find the values of x. These are turning points, which happen when x is equal to 0. Oh, okay. I'll check it out. I'm teaching now. Yes. Pardon? Yes. I'll send you a class. Sorry for that, friends, for disappearing. Are we still together? Am I audible? Okay. So I am saying for values of x, now I said when you equate, like y is equal to 0, these are actually not turning points, but where the graph is cutting this, like cutting the x-axis. So for values of x, so mean that the graph is going to be cut at 0, at 1, and at 2. For values of x smaller than 0, you see the function is negative. Negative means it is on the negative values of y. So this means it's down. Between 0 and 1 is supposed to be positive, meaning that it's going to be like something like that. Okay, and then between 1 and 2, the function is supposed to be negative, supposed to be like that. And then above 2 is supposed to be negative, like that. So this is a function. That's how you sketch polynomial functions. All right, so this is the f of x. Now find the area bounded by the curve and the x-axis. The area bounded by the curve and the x-axis. This is the curve you're able to see, and then the x-axis bounded by. So you want the area between this area here. That's what you want. So the question is, how do you find that area? So I've seen that some portions are on the negative y and then some portions are on the positive y. So I'm going to differentiate the way I'm going to be finding. I'll first find the area which is on top. But I think this graph is symmetrical, meaning that the area on top should be equal to the area down. Now, application of area, this is integration. So to find the area is going to be the integral. I'll start by the limits. The upper limit I'll get 1, the lower limit I'll get 0. Like I want to find the area above here. So the x value, the upper one I'll get 1, the lower one I'll get 0. What's the function? The function itself is this one. Now, again, I need to multiply this. So I'll say, of course, this is x squared minus x, open brackets, x minus 2. I've just multiplied this x by what is inside here. Again, multiply x squared times x, that will be x cubed. X squared times negative 2, that will be negative 2x squared. Negative x times x, negative x squared. Negative x times negative 2, positive 2x. So this is going to be x squared minus 3x. This is x cubed minus 3x squared plus 2x. Okay, so this is what we want to find the integral for. So the integral of x cubed minus 3x squared plus 2x dx. Please don't forget dx. This is going to be area 1. And then I'm also supposed to find area 2. How do you find area 2? You look at the graph which is below the x-axis. Okay, so the upper limit is 2, the lower limit is 1. Now, since it is below the x-axis, I'm going to attach a negative here, otherwise we're going to find a negative area. Okay, and then I'll write some x cubed minus the 3x squared plus 2x dx. And then let's get to integrate. This is going to give us x to the power 4 divided by 4 minus, if you add the 1 to the power 2, that will be 3. So it will be 3x to the power 3 over 3, which is just x power 3. And then to 2x, add a 1. It becomes 2x squared divided by the same 2. It will be 2x squared over 2, which is just x to the power 2. And then the limits, the upper one, I'll put it here. The lower one, I'll put it here. So I'm supposed to substitute the upper limit minus I substitute the lower limit. So let me put the upper limit. 1 to the power 4 is still 1 over 4. Minus 1 to the power 3, that is still 1. Plus 1 to the power 2, that is still 1. I was supposed to subtract minus. I substitute the lower limit, which is 0 in the function. So it will just give us 0. This and this will cancel. So that will just be 1 over 4 units squared. And then we'll come this side. This will still give us x to the power 4 over 4 minus x to the power 3 plus x to the power 2. Upper limit is a 2, lower limit is a 1. Substitute the upper limit. So the upper limit, that is going to be 2. So that will be 2 to the power 4. What value do we get, friends, mathematicians? 2 to the power 4, 16? Elizabeth?
16.
Okay, that is going to be 16 over 4. That is a 4, right? I hope you are seeing what I'm doing. So I'm getting the upper limit, which is a 2. I put where there is x. So 2 to the power 4, we are saying that is 16. 16 over 4, that is a 4. Minus, put again 2 to the power 3, that is it 8? And then this one here is x squared. So 2 to the power 2, that is a 4. We're supposed to, there is a sign which I've left out here. I'll come back to it, okay? Minus. Now substitute the lower limit. The lower limit, this is a 1. We know that if you substitute 1 in this function, we're going to get 1 over 4. Like this one will be negative 1, so will be positive 1. It will just cancel. Okay, this is going to be 4 plus 4 which is what? 8 minus 8. So this is going to give us 0. So we just have 0 minus 1 over 4, which is negative 1 over 4. That is why I attached this negative you are able to see here. Okay, this negative, I just didn't attach it because the graph is down. So I'm supposed to attach that negative. So if I multiply now this value by that negative, it becomes positive 1 over. So that is why I was saying this graph is metric, meaning that the area on top is going to be the area down. So if I know this area, just multiply by 2. So therefore the area for this function is going to be 1 over 4 plus 1 over 4, which is 1 over 2 units squared. That is it. Okay, and the very last question in this paper. We have answered every bit of question, any question in this paper, from question 1 to the very last question. So if you've not checked out the tutorial video on this one, please be sure to check it out. Because like they repeat questions. SAP is an exam, like it's just the same exam. You'll find they'll just change years. Just a something. Anyway, so consider an experiment in which a colony of live bacteria is introduced to a limited food supply. Suppose the rate of change in the number n of live bacteria with respect to time is given by dn over dt, which is going to be equal to 6,000 t squared minus 75 t to the power 4. Find the size nt. Okay, find the size nt of the population at time t if initially 100 bacteria were introduced to the food supply. Now remember this expression which we have here is what? The rate of change in number n. Okay, the rate of change in number n. My question is asking us to find the size. The size. They've given you rate. So this is rate is actually size divided by time. You can see dn over dt. It is size divided by time. So what I'm going to do here, I'm going to find dn, cross multiply both sides by dt, so that will be 6,000 t squared minus 75 t to the power 4. It becomes here dt. Since I want to remain with n, which is the size of the population, I'm going to integrate both sides. Every time you integrate d something, it will be 1. Okay, like uh it will be that same constant. The integral of dx is x, the integral of dy is y, the integral of dt is t, the integral of dn is n. So it's going to be n. And then integrate 6,000 t to the power 3, that is going to be 6,000 t to the power 3, like it was power 2, sorry. And then the same 3 divide. Minus 75 t to the power, add 1, 5, divide by the same 5. Add a constant c. So meaning that n is going to be 3 into 6,000, that is 2,000 t to the power 3 minus 7. Oh, 5 into 75, mathematicians again. What's the value? So 5 into 7 is a 1, remainder 2, 5 into 5, 25. And then plus c. Now remember, initially at find the n population at time t. Initially 1,000 bacteria were introduced. So when the time was 0, that is initially, you had n being equal to 1,000. So we want to find the value for c. So put 1,000 here, where they still put 0, where they still put 0. So I'm going to find that c is equal to n, which is just 1,000, meaning that n, which is the same one they're calling nt at a particular time, is going to be equal to 2,000 t to the power 3 minus 15 t to the power 5, and then plus c, which is 1,000. So this is the size expressed in terms of time. So if they give you like after maybe 5 hours or 5 days, you can